Good computing in the cloud. As usual, we're going to kick things off with a few polls here, so bear with us. If you wouldn't mind just answering the polls, the answers will be shared with the entire audience, so good learnings for everyone. And the first poll should be up, and it looks like this is around, what is your current grid processing situation? So if everyone would please just take a quick second and click one of those boxes. Great, thank you. Interesting. So looks like the majority of you are looking to take advantage of something in the cloud. A decent chunk satisfied with what you have, and then looks like some projects on the horizon. Great, very interesting. So thank you, appreciate that. So let's kick off the second poll. This one is around essentially what type of grid applications are you running? So a little bit about what those workloads are. Interesting. Okay. So it looks like we have quite a few folks out of the scientific community here, pharmaceutical and whatnot, and then a lot of general batch processing. Great. Thank you. So let's do the last poll here. And this one is specifically, what are you doing today in the cloud, if anything? Okay, it looks like we have quite a few explorers, and a few of you looks like you're pretty advanced, so about a fifth there are actually doing serious projects in the cloud today. Well, good, that's helpful. So I think you'll all find this webinar is very suitable then to this audience and these characteristics, so appreciate that. So again, welcome. Thanks for joining us today. I wanted to give a quick call out before we get going. Those of you that are in the Mid-Atlantic, New York, and New England region, next week, as you may know, is the New York City Cloud Expo. That's at the Javits Center. It starts on the 19th and goes through the 22nd. And RightScale, in conjunction with Cloud Expo, will be hosting our second user meetup. So this is a free event. We're going to be talking a little bit about our roadmap, cloud trends, both customer trends as well as general market trends. And we actually have 4 different customers who will be speaking and talking specifically about their use cases in the cloud. There'll be a cocktail party that evening. All of this is free of charge, so if you are planning on going to the Cloud Expo or would like to, please check it out. You can register at rightscale.com/meetup, and that registration will also automatically register you for the Cloud Expo as well. So hope to see you there. Well, let's dive in. Let me first introduce the panel today. So this is Josh Frazier speaking. I'm the Vice President of Business Development. Today I'm joined by Daniel Knight. Daniel heads up product marketing and is also our domain expert in grid computing. Here with me is Dave Welch, one of our sales engineers. So Dave, as usual, is going to be taking us through various attributes of the RightScale system. And then I'm joined on the Q&A log by Andrew DeMille, one of our account managers. For those new to RightScale webinars, please feel free to ask a question at any point during the webinar. We'll be answering questions throughout, and then as always, we'll be leaving time at the end. And then provided questions still come in, we'll stay online for as long as questions come in. So if you want to hang around past the hour, feel free to do so, and we'll keep firing away and addressing your questions. Well, let's dive in. So today's agenda, we're going to do a quick welcome and just baseline a few things by introducing you to RightScale, what this is all about, and where we fit in. Then I'm going to turn it over to Daniel, and he's going to talk and take us through specifically some of the various challenges that grid computing introduces in a traditional data center environment, so both administrator challenges and user challenges. And then we're going to transition and talk about how cloud computing in general and then RightScale management within cloud computing specifically addresses these challenges. As usual, we'll spend some time in the RightScale system itself, so you'll see some production workloads taking advantage of what we're talking about here in the presentation live, and Dave's going to take us through that. And then, of course, that Q&A that I mentioned, fire away at any point, and Andrew will address those, and we'll weave those into the talk as well. So with that, let's get started. So RightScale. RightScale is a cloud management system. We've been doing this for quite some time. To be exact, a month after Amazon launched their EC2 service, RightScale launched. So we're coming up on 4 years this fall. We're proud to say that we're behind the largest and most complex and biggest scaling events in the cloud today. We have over 30,000 users on our platform, and we've launched and managed over 1 million servers. In fact, part of the meetup next week, we're giving away an iPad for folks that can guess closest to the number of servers we will have launched by April 21st. So if you're interested in an iPad, you can go to rightscale.com and take advantage of that contest. So simply put, we've been at this for a while, and we have a ton of experience in understanding a wide range of customer offerings and different cloud-based workloads. This ranges from small startups all the way to Fortune 100 companies that I'm sure you've heard of, companies like ESPN and Eli Lilly. Specifically where RightScale fits in, we're the orchestration and automation layer between the applications you want to run and the cloud infrastructure providers themselves. So providers like Amazon Web Services, Rackspace, and more getting into private and hybrid cloud solutions. RightScale, again, is a multi-cloud system that stitches together a lot of these resource providers to enable you to more easily, quickly, and more effectively take advantage of the great offerings that these cloud providers have. With that, I'm going to turn it over to Daniel, and I've asked Daniel to take the audience through a couple key things, specifically starting with some of the challenges that we see within grid computing, both on the end user side as well as IT administrators, and then tie that into what the cloud means to addressing these challenges, both in general and also specifically layering on RightScale's management system. So Daniel?
Thanks, Josh. So, grid processes and many back-end batch processes are run periodically and can have very large server requirements. Often they're fundamental to the business and often to research and development groups. I saw a study recently that said that over 60% of applications running today in the distributed environment run some form of batch processing in the back end. Some of these jobs we find run cyclically, and some are well scheduled, but others are rather what we call one-offs, where the team requesting the job are working on new algorithms and with new data, and they need to have a real hands-on connection to the servers that are running it. What we often find is that our customers are in a balancing act between having enough compute power and not wasting resources. Many large IT organizations today dedicate staff time to support the constant provisioning and commissioning of these servers so that the special project timelines can be met. What this often means, though, is that users are waiting in line, and there's often a limited amount of servers to run their grid processes. This also means large costs to the business, both capital and operational. It's not just having the physical servers, but it's all the setup time it takes. These processes often take very specialized IT disciplines for the servers themselves, the software loading, the networking, etc. And because resources these days are very limited, running large processes can take time. So let's take a look at running these processes instead of on your traditional resources, what it looks like when you run it in the cloud. Josh? So instead of running your grid processing and grid computing in your standard data center, when you move to a cloud model, many of these issues that you were struggling with before in your own data centers actually become a thing of the past. There's no longer a need to purchase enough servers to meet peak demand anymore because resources are available on demand and they can be turned off when you no longer need them. With virtually unlimited resources in the cloud, scheduling conflicts totally go away because each job has access to a virtually infinite resource pool. Jobs can even be completed faster for the same cost by just using more servers for a shorter period of time. And that's what's so great about it, is that you only have to pay for the resources that you actually used and for the actual time that you're using them. So running the same job on 10 servers or 500 can end up costing the same. It's all based on the number of hours that you use. So let's look at running these same type of grid computing processes using RightScale. RightScale offers a solution pack that will enable you to quickly provision grid applications. We allow you to work at a level above the raw infrastructure that Amazon and other cloud computing providers offer, and that way you can work in the systems management level rather than sets of scripts and programming interfaces alone. As cloud computing providers add features, RightScale complements the raw technology and the infrastructure with higher-level templates, automation, and frameworks. The whole intention is to provide management functionality that allows the development of application architectures from the bottom up, but also provides pre-configured frameworks that you can customize for your specific application requirements. With RightScale, an administrator, instead of handling 30 to 50 servers traditionally, can handle hundreds or even thousands of these cloud-based servers. Adding to that, there's the full RightScale value. The RightScale platform provides users cost transparency, accounting roll-ups, user management, and the projects can be broken down by the user or the department in a way that fits the specific organizational structures. Costs are tracked, reviewed in real time, and you can even project through the end of the month. For organizational budgeting purposes, RightScale rolls up costs and exports them for further analysis. But why don't we look at some different real-world examples, Josh? So these are some of the different examples that we found in looking at our existing customers, where they were looking to do cloud-based grid computing. And there's all different types of industries that get attracted to the cloud and thus to RightScale to manage their processes in the cloud. Companies that do pharmaceutical analysis, where the researchers are looking at protein analysis and comparing millions of different compounds. And what they were finding was that it would take quite a bit of time to do this type of analysis on internal servers. But using RightScale, they were able to do the job really in less than a day. Often when we've talked to pharmaceutical companies and the processes they're working with and how they're leveraging RightScale, their main reason that they use us is because their issue is how quickly can they get a drug to trial and thus to market. Similarly, we work with organizations that do insurance claims loss control, where they're looking at detecting fraud within all the different claims that they're given. And they do their batch runs on the cloud, and they're able to do this at a significantly lower cost using RightScale. Because Web 2.0 has taken off so quickly, we often find Web 2.0 type applications using RightScale as well. Not just for their front-end applications, but also for their grid computing needs as well. One customer actually does transcoding, where they actually do video on demand, and they use us in order to bring their transcoding requirements to the cloud so they can get it done in near real time. We also find financial services companies who have to do data processing, where the back testing of the environments, they need additional compute capacity from time to time to analyze data to trading strategies. And what they find is that they can do this faster and more cost effectively by scaling out servers. But I think the reason they really like RightScale as a partner is that RightScale enables them to manage their SLAs in a cloud model, just like they would in an internal model. So Josh, let me hand it to you, and you can go into the RightScale grid computing solution packs and how we're packaging this up today.
Great, thanks, Daniel. Appreciate it. Yeah, so today we're proud to announce our second cloud computing solution pack. Our first one, as some of you may know, was specifically geared towards social application providers. But today we've rolled out a new solution pack specifically architected for grid computing. What this is a pre-configured framework that, simply put, is everything you need to run a complete, scalable grid application in the cloud that is automated, resilient, and auditable. It leverages and incorporates proven best practices that we've learned through over launching and managing over 1 million servers on how to piece together the various different resources, in this case provided by Amazon Web Services, things like EC2, SQS, their simple queuing service, and their storage resources, as well as best practices around architecting across multiple AWS regions. Those are discrete standalone data centers. They have one on the east, one on the west of the U.S., one over in Europe, and soon to be one in Singapore, as well as across multiple availability zones. And we'll get into some details as why that's important later on. And then finally, what all these solution packs also include is bundled offerings that include PS support from RightScale experts, so they will help fine-tune your environment and help you get up and running quickly, as well as ongoing support so that when you need it, you can talk to a human being 24/7 on the phone to help you troubleshoot and be successful in the cloud. So this is just launched today. You can find out more details on rightscale.com. But let's take a look at what this includes. And to start off, we want to take a look at the high-level architecture of what this RightScale Grid Computing Solution Pack embraces and delivers to our customers. So first we have a component here which is really the RightScale Job Coordinator. And this is leveraging both job producers and job consumers, which may be run locally or may be run in the cloud itself. There's various different ways that you can plug into the RightScale Job Coordinator to take advantage of a process from a producer and consumer standpoint that you may be used to using today. Secondly, it provides a lot of the orchestration and automation around how to deal with various different input files that are located in different S3 buckets. And then from there, it's the orchestration and automation around how to manage, monitor, audit, and then react through a series of escalations and remedial actions on different things that are occurring within your queue when you're running your workloads. So let's deconstruct this and take a look at the three main parts of the process. We're going to start first with the job coordinator. So here we have a situation where the job producer creates the input files and constructs the work unit. From there, the input files are loaded up into an S3 storage bucket. Finally, the work unit is packed into a message, and then the message is placed into the simple queuing service queue on Amazon. So Dave, now one of the questions we get is, can customers run their job producers locally as opposed to having to deploy them in Amazon? You want to talk a little bit about that?
Yeah, sure. So you have the flexibility to submit your work units either from internal infrastructure or from the public cloud. You just need to have the flexibility, or you just need to have the tools to submit these jobs to the S2S queues and upload your files to S3.
Yeah, that's one of the tenets of RightScale. We try to keep things as open as possible. So our automation and orchestration is around the infrastructure components. We want customers to be able to leverage existing resources they may have internally, and then of course their application is their application. So we're not touching that.
No, that's right.
Okay. So let's move on and take a look at the next step, which would be the actual work queue and work unit processing. So now that our inputs and work units are loaded into S3 and the SQS queue, let's take a look at the flow around the processing itself. So first, RightScale, based on automation settings that you as a user can configure, will instantiate an environment. This can be a single server or a multi-server worker array that's ready to accept jobs. You can also configure it so that RightScale will automatically kick off that first job or wait until you manually configure it. So RightScale will bring all of these resources online automatically based on definitions that you're presetting within the platform. The next step is the worker daemon will copy a message out of the work queue, unpack that message, and then download the respective files out of S3. From there, the application code is called with the message, and the worker begins doing its work. The output files and the logs are placed in the appropriate directories. And then finally, the results are then returned back to the daemon for further results processing. And so with this, I just want to emphasize again, and maybe Dave, you could comment quickly on what modifications actually need to be made to the application itself to take advantage of this type of grid computing environment.
Sure. As you can see here, very little modifications are necessary to your application. It's still just going to be operating on local data and RightScale will take care of the orchestration of sending your work units to the appropriate queues and uploading your result files to the appropriate buckets.
Got it. Okay, let's move on to the last major phase of this process, which of course is results handling. So let's take a look at some of the automation procedures that RightScale delivers around this. So first, the output and the log files are uploaded into the respective buckets in S3. Next, the temporary and input files are deleted. And then from there, RightScale is leveraging a series of pre-built results queues. So this is also an area where RightScale is automatically orchestrating the creation and management of a results queue, an error queue, and then an audit queue so that you can react accordingly based on the results of your job. The statistics are placed in the audit queue, and then of course the final step is deleting that message out of the input queue and thus completing your work. So now that we've taken a look at kind of the three main pieces of that grid computing process, I want to turn it over to Dave, who's going to take us through our first demo. And specifically what Dave's going to show us is how, using what we call a RightScale macro, you can automatically build out an entire grid computing system within RightScale that automatically will start generating workloads. He'll also talk a little bit about the various different ways that job coordinator with RightScale accepts plugins through what we call inputs within RightScale. And then a key value here is that you as an administrator can take advantage of a proven, very graceful way to provision and deprovision resources in the cloud environment. A lot of this remediation is handled automatically by RightScale, so you don't have to worry about it as an administrator. So Dave, why don't you show us what you got here?
All right, thanks, Josh. So as Josh mentioned, I will show you over the course of 2 demos how you can set up your grid environment end-to-end using RightScale. To do so, I'll start by executing our grid macro, which will build out our environment, the one that was just referenced in Josh's slides. So I'm going to launch the RS Grid Quick Start macro, and this first screen that I'm presented with is going to ask for some cloud preferences. So the SSH keys and security groups or firewalls that I want associated with my groups of servers.
And so, David, it looks like you have several that have been preset there. So that, again, looks like something that you can set ahead of time, and then during the runtime, allow yourself the option to configure it as you see fit.
That's right. And now that I'm executing the macro, you can see it's building out that entire environment that Josh just referenced. It's building all the queues, it's building the servers within our deployment, and it's also building out the scalable queue-based array.
So this macro then is essentially a definition of a system that you're building within RightScale automatically.
That's right. So we have a server template that has the definition of a server configuration, and then a macro would be the template for your entire infrastructure build.
And that's an important point, because what we see quite a bit done in the cloud, particularly larger organizations who will have multiple project teams, multiple products, multiple workloads, they want to create a certain amount of isolation. They want to codify and leverage best practices, but they don't want to have to rebuild or reinvent the wheel every single time. So by using this macro, you essentially have defined an entire system, and then there's a sharing mechanism within our platform, and then through that drop-down of various different security groups and SSH keys, you can create isolation amongst work groups and project teams, but leverage the same work once as an organization. So design and deploy once, and then leverage that through multiple different groups within your organization.
And execute that out to build out multiple grid environments. Okay. I jumped to the deployment page so you can see the groups of servers that we built out. And as you can notice, so it built out the entire infrastructure, and it's also automating bringing up the job coordinator and a worker instance. So I'm going to jump in the deployment to show you how the logistics tie together via what Josh mentioned earlier in our inputs. So the inputs that are defined are inherited by all the servers, and it lets them know which queues they're using, which buckets to upload the files to. So all that orchestration is taken care of, so we set defaults for best practices that your job producer, when you plug it into the environment, can use, and all the logistics are taken care of.
And Dave, these inputs, essentially, these are environment variables, and these can be either fixed by the administrator, or these can be called upon as variables, during runtime that the user would have to configure.
That's a good point. So it can be dynamic, based off the server template methodology. So when a server is brought up, it dynamically configures the server and consumes these input variables, so it knows where to send the appropriate messages and upload the files.
And this methodology is really key to understanding best practices within cloud-based deployments, because instead of having to deal with static images where every single time you're changing something, you have to rebundle and upload that image, which can take a lot of time, be prone to error, using essentially these server definitions, what we're calling server templates. And then further, these server templates are grouped together into macros, which will build out entire deployments. You have essentially a component-driven architecture. So you can change a single component within this environment, and then that component is inherited by the entire deployment.
That's right. It's very modular, and as you mentioned earlier, it can be used by multiple groups to create multiple grid environments without having to rebundle their images.
And in this particular case on the queues, obviously, that example of moving to different work groups, this same architecture, but allowing them to run their own jobs, they're going to have different queues.
Exactly. So I just jumped into one of the scripts here, and I just wanted to point out the inputs, which abstracts all these details out, which allows you to create multiple environments without having to re-architect. So within this script, this is just a configuration file. I'm going to point out that it's specifying which bucket to use, which I can define via one of those inputs.
And Dave, I just want to call everyone's attention here. Over to the left, it looks like, so not only have we created this environment for grid computing, but it's actually started to kick off jobs.
So it's kicking off jobs right now, and it's bringing up some of the servers. And as we mentioned earlier, the server templates is taking care of the configuration of each of those servers that are launching.
Got it.
All right, so now I'm going to hand it back to Josh, who's going to go over different ways we can scale your environment.
Great, thanks, Dave. So what you just saw was how you would use RightScale, and specifically RightScale macros, to pre-build a grid computing system on RightScale. So this is one of the key elements to the grid computing solution pack, is customers of that solution pack have access to this macro and can do, in what you just saw Dave do, to take just a few seconds, can actually build out this architecture that's ready to accept workloads. The next thing I want to talk about here is automation. And what we hear quite a bit within the cloud, and this is obviously inherent in any sort of grid computing workload, is automatically deprovisioning and provisioning, so essentially auto-scaling. There's several different ways in which RightScale approaches this, and like everything within RightScale, this is configurable by the user. We'll help you with fine-tuning, but really you have the flexibility to architect this however you see fit. The first category of array scaling is based on alerts or schedules. So alerts are simply taking advantage of a whole series of system-level metrics that RightScale is monitoring. RightScale itself is a rules-based system. So any metric that RightScale is monitoring can trigger what we call an alert, and then further an escalation, which is a remedial action that RightScale will take on behalf of the user. So alert-based scaling is a very common approach towards growing and shrinking your environment. So you can be monitoring things like disk I/O, CPU idle time, requests, things of that nature, and have those trigger different resource changes based on metrics that you set. The next component of array scaling that we see used quite a bit is schedule-based scaling. So this is pretty simple, day of week, time of day. If you happen to know when you need to run your job, and you have a good idea of the amount of resources you're going to need, why not just schedule it to be available upon when you're going to launch that first job? So I want to turn it back over quickly to Daniel, because we see, Daniel, customers that take advantage of both alerts and schedule-based scaling within their arrays. So maybe share a little bit more with the audience of what we're seeing there.
Right. In terms of alerts, many Web 2.0 applications are having a lot of random I/O requirements. Grid processing, with the alerts that RightScale has in the platform and in the solution pack for grid computing, offers them the ability to handle near real-time results, and it allows you to map these to your needs. In terms of schedule, I often see financial services companies having a fairly good understanding of what those requirements are, and there's many other types of companies that are looking for ways to economically handle their scheduled back-end processes for end of day, month, quarter. What we're doing is we're making sure that the results map to your SLAs. Instead of having those servers also underutilized for the majority of the time and then just used for that process, you can actually take these processes and put them on the cloud. It's an ideal usage of a RightScale.
Great, thanks, Daniel. So the next type of array scaling and automation that we have is based on various attributes of that queue. So again, RightScale with this grid computing solution pack, we're orchestrating, we're monitoring, we're automating a lot of the different resources that Amazon is extending from their infrastructure cloud. Specifically on SQS, we're looking at a couple key things. You may want to set automation around the total number of messages that are residing in that queue. So that's something we see very common within our grid customer base that they take advantage of. The second is you can look at aging. So essentially, how long has that message sat in the queue? There are very specific use cases where you take advantage of that as well. And then finally, there's intelligence within RightScale that understands the economic and the charge model of the cloud providers themselves. In the case of Amazon, when it comes to instance utilization, you're paying by the hour. So RightScale knows that if we've provisioned an instance for a customer, even if that instance may remain idle or not at full capacity, we're going to let that instance run for the maximum period of time before the RightScale system will take another automation step to figure out if that instance should be terminated. You paid for it for the full hour. You might as well get as much utilization out of it as you possibly can. So Daniel, I know we have customers that take advantage of queue statistics as well. Why don't you share a little bit more about that?
Absolutely. It all comes down to efficiencies. I often see this in insurance requests as well as pharmaceutical organizations. And they're used by groups where any of their processes, speed becomes the key element here. And what they're trying to do is they're trying to increase their speed of getting the results. And what we've done with the queue statistics is we've made that adjustable. And it's simply adjustable to you. That way you can meet your internal SLAs for these types of batch processes. Josh?
Great. Thanks, Daniel. So with that, let's take a look at some of the key benefits here and what this automation really enables you as a user to take advantage of. The first is this automatic remediation. So again, RightScale is monitoring and reacting to a whole host of things that are going on within your environments. And there's automation around not only dynamically configuring your instances based on certain attributes of the queue, but also things around load-based scaling that Daniel mentioned. So simply put, we take a lot of the manual heavy lifting off of your plate and put it on the platform to do automatically. Second is this grid computing solution pack is specifically designed to also handle complex batch processing. So what we call chaining, where you have the outputs of one process become the inputs of the next. So it's very easy within RightScale, just like you saw Dave do on that initial environment, to modify that macro to handle a chaining type process. Next, you have this efficient spending capability. So here, this is what I talked about earlier, which is RightScale understanding the economic model and the charge model and the unit of measurement within the various different cloud providers that we support. Our system is constantly monitoring the various attributes of these clouds and making smart decisions that you as a user can set so that we know, hey, if this resource has already been paid for, take advantage of it as best we can. Send it load to maximize its utilization based on thresholds that you as a user set. And then finally, there are a whole host of different ways that RightScale can help you lower costs. Of course, the cloud in general is a pay-as-you-go model, so right off the bat, there's a huge cost savings opportunity there. But further, within RightScale, you have the ability to decide specifically where you want to place resources. These resources cost differently. They cost differently based on what region of Amazon they're being launched in. They also, of course, have different costs based on other clouds. So you within RightScale have the ability to decide where you want to pull resources out of. So that's one way that you can help manage your costs. The second is RightScale has full support for Amazon's reserved instances. Reserved instances are ways that you can essentially buy down the rate of that server. So instead of paying a certain amount per hour, you're paying a small amount up front and buying down a lower rate. So RightScale also has the intelligence to know that if you've purchased reserve instances, we're going to send workloads to those instances first to make sure that you're paying the lowest possible rate. And then finally, Amazon just recently came out with something they call spot pricing. And RightScale also has support for spot instances. And think of this as a way to basically set the rate that you're willing to charge. So eBay for the cloud. So you decide what you want to pay. And if RightScale finds that price available, we're going to launch that instance under that spot price for you. You don't need to do a thing. So just a sample of a few of the ways we can help you save costs. So with that, we're going to turn it back over to Dave, and we're going to take you through the next part of our demo. And two key areas we're going to focus on. So one, Dave's going to show us how you would go about doing some of the common configurations of the arrays that we just talked about earlier. And then second, if you recall, we actually kicked off a job. So you saw those instances that we're launching during the first part of the demo. We're then going to dive in and take a look at what happened. So we're going to take a look at the results and talk a little bit about that.
Thanks, Josh. So I'm starting on the deployment page here, and this is just the deployment that we created in the first demo. But now I'm going to dive into one of the queue-based arrays that we have to talk about some of the different scaling options. So within an array, you have certain server options that you can set. And as you can see, each server within this array is based off a server template. And as I mentioned before, the server template allows for flexibility and repeatability when you're creating your server image.
So that same server template is launching multiple instances, so you're not changing that.
Exactly. So it goes back to the point of design it once and then reuse those components again and again.
And it looks like you're also defining at the server template level the specific resource pool that you're going to pull that resource out of.
Mm-hmm. That's right. And also, to finish off the server options, you can set certain cloud preferences. In this case, this is inherited from that macro I ran, but the SSH keys and security groups and the instance type that you're launching on.
And the instance type, these cloud providers offer a whole variety of instance types, so essentially the hardware configurations and the hardware attributes. So here you're defining this as a server template to take advantage of an M1 small, but you can use that same server template on a future server launch to take advantage of a Quad XL if you wanted.
No, that's right. And if I find out that I want to vertically scale these servers to use a larger instance, all I would have to do is edit the instance type, and every future server that's provisioned within this array will be launched on a larger or medium-sized instance.
So Dave, I think an interesting point would be, what would you have to do if it wasn't using a server template approach? What would you have to do in the image configuration with the cloud itself?
You have to bundle all your application code into it, all the logistics of pointing to the right queues and the right buckets. But then again, if you wanted to reproduce that environment for another grid environment, then you're going to have to launch those images and reset those configuration files. So next up, we have the server allocation policy. And this allows me to set certain min and max counts. So as you can see here, I have one server running in this array at all time. And it's best practices to keep at least one server up, depending on the size of your cluster, so it can process the results immediately as they come in. And then next we have the max count. And since we're running a small demo, we've capped it at 10 servers. But as it grows, it can get into the tens or hundreds or thousands of servers. In this case, we capped it at 10.
So Dave, on that min count and thinking back to that schedule-based automation, if I wanted and I had a good understanding that, hey, I'm running this job every day, I'm doing an analysis on a DNA strand, and I know precisely what it requires as far as machines. So if I wanted, I could actually set that min count to be the specific number of machines that I'm going to need for my job. And that would create greater efficiencies to allow that job to actually get done faster, because it would provision all those resources at the same time.
Provision them all at the same time, and then you could also scale up from there. The last thing I wanted to mention about the max count, though, is that you can cap it to prevent yourself from scaling further than you would like for budget concerns.
And then on here, it looks like within this AWS US region, it's pulling out of all of the availability zones within that East region. But if I wanted, I could actually select which specific availability zone I want to place these resources, which we actually do see quite a bit for performance reasons.
Yeah, so for any latency requirements that you need, you might want or might need to launch servers in the same availability zone. But for this demo, we don't care which availability zone it is. We just want a server to come up in any of those availability zones. Okay.
Great.
So next we have the queue options, and this is what Josh touched upon earlier. In this case, the elasticity function is we're scaling based off the amount of jobs in the queue. And in this case, we're launching, so every 3 jobs that we have, we're going to provision an additional server. But we can also scale based off a different type of elasticity function, and that is based off the item age. Now, the item age is usually used for to meet SLA requirements. So if you have a job that's been in the queue for about 5 minutes and you need to meet your requirements, we'll then go ahead and provision additional resources.
I think an important thing to note here too is that with these quick start deployment macros that are part of these solution packs, we're doing a lot of the initial default configuration for you. So we're taking best practices, we're taking learnings from all of the experience we've had with launching over 1 million servers and packaging them up. But if the customer wants, they can certainly change these. So there's fine-tuning that can happen. All of these variables that we just went through are configurable by the user. And then furthermore, part of that grid solution pack involves an engagement with our professional services team. So the subject matter experts who have done this time and time again that'll help customers actually do the fine-tuning on their environments to meet the specific needs of their application.
Now, that's a great point. And, RightScale really provides those defaults to get you started as quickly as possible, but it's also a good point that you can control any of these aspects within the grid environment.
So let's see what this thing did. Let's take a look.
Okay, so I'm going to jump back to the front page, and so I'm going to go into one of the front-end servers, which is going to show the input files and output files. So as you can see here, we have some input images, and what this grid process is doing some image analysis on some images or converting images into different images. But now we have to run the job consumer to consume those output results to see how they worked out.
That's a motley looking crew, Dave.
So now I'm gonna dive into the deployment here, and I'm gonna run a script to consume the jobs or run the job consumer.
And is this script something that could be configured to run automatically by RightScale?
It's actually best practices to keep the job consumer running at all times. But for the purposes of this demo, I'm just going to run it once to consume those jobs.
Okay.
So this is also a good point to show that within RightScale you can run operational scripts for any remediation that you might need or any code updates.
And again, these are all defined at a server template level. So a single server template is including and defining a whole host of dynamic configuration parameters. So not only operational scripts, boot scripts, that while that instance is booting up, RightScale will dynamically configure it, but also during runtime, you can do this remediation through operational scripts. And then finally, we have that notion of gracefully deprovisioning out of the cloud, and that's where the RightScale decommission scripts come into play. All packaged up, defined at a server template level, and then these deployments, which this macro automatically builds, are stitching together multiple server templates.
No, that's right. Excuse me. I just wanted to point out that I kicked off the job on the side here, so it's currently running. And then so once it's finished running, I'll jump back into the results page to view the output images.
So as far as log file consolidation, audit entries, so RightScale is aggregating and recording all of that. So that's also very important for a lot of all customers, but particularly enterprise customers who need to make sure that they're preserving control and an auditable environment so they can go back and figure out who did what when.
Yeah, and sometimes you need to put the blame on someone if something goes wrong. So I'm going to reload this page. And here, as you can see, with the first 2 work units, we got results back. But what I want to point out is on this third image, there was an error. And to figure out what went wrong, we can jump into the error queue to view the error message. So now I'm going to go to the queues section. And before when we ran that macro, it built out the entire environment, including the queues here. So we can see that within this environment, we finished all our jobs, but we do have one job in the error queue. Now to view that message within the dashboard, I'm just going to view the top item. And as you can see here, there was an exception that was thrown, and that was due to an incorrect job worker that was sent within the message.
So David, it looks like just to clarify and make sure that we all understand this. So the automation within RightScale is creating these various different queues, and then further there is optional automation around the message handling within each queue. So this error queue could have kicked off what, for example?
It could kick off if there was a default class that you wanted to run. You can consume it just like the job consumer, so you'd be consuming the error queue. You can kick off an alert to alert someone that an error has happened within the grid environment. So there's various other remediations that you can take.
Got it.
So now I'm going to hand it back to Josh, who's going to go over some of the economic benefits within a grid environment.
Great, thanks, Dave. So I hope you all enjoyed the demo, and what Dave just showed you was not only the results of that macro that instantiated that environment and kicked off that job, but also how you would go about configuring various degrees of the automation within RightScale's server arrays. So let's end now with benefits. So what's this all mean? What's the impact on you as an organization, as a user, as an administrator? So there's a couple key areas. The first would be more around the hard cost benefits. So Daniel mentioned this earlier, but inherent with the cloud is no CapEx. So you're paying as you go. So you're not shelling out significant amounts of dollars to basically build your environment to peak load. When you need resources, you can get them. The cloud, with its pay-as-you-go model, allows you to only pay for what you've used. And then finally, RightScale is delivered as a software as a service. So you're paying a single monthly subscription as opposed to having to worry about transferability of licenses, maintenance contracts, having different user groups or subsidiaries take advantage of that license. So this is a subscription-based platform. You're paying for it once per month, and you can take advantage of that platform across multiple different user groups. But the next area, and perhaps the most important area, often gets overlooked, and that is what grid computing in the cloud with RightScale does to business agility. So simply put, imagine how your world changes where IT resources are no longer a hurdle. A couple things specific to grid computing. One is this notion of your job is always first. So you're never having to worry about some more important job bumps you down, and you have no visibility into when that job's going to be complete. That characteristic is extremely important, and we see this all the time with our pharmaceutical customers. So having that transparency of when that job's going to be done allows research scientists to get dramatically more efficient in performing their workloads. The second is this notion of unlimited resources. So you're no longer bound by the finite data center that you're running internally. So if you need 10,000 servers to run your job, you can go get 10,000 servers. And then finally, this notion of pre-configured proven architectures. Because RightScale is delivered as a platform, as this software as a service system, all of our users and customers are taking advantage of all of the pre-configuration and best practices that we've learned over 3.5 years and over 1 million servers of deploying in the cloud to date. So specifically within the Grid Computing Solution Pack, one of the things you take advantage of is that quick start deployment macro. So exactly what Dave ran, you get access to that as a Grid Computing customer and take a lot of the heavy lifting off of your plate and put it on the platform. Wanted to talk a little bit and paint a picture around this notion of agility. And here's the power of this, and here's really what we're talking about at the end of the day. Let's say you have 10,000 jobs that you need to run, and you're going to run them in the cloud. So one option is you run them as you normally would, perhaps in your traditional data center environment, on 2 servers. Okay, so that processing time may take 500 hours. You can take that same batch of 10,000 jobs and in the cloud fire up 1,000 servers, bringing that processing time down to a single hour. And guess what? You're paying the exact same. So that just gives you an idea of the power of this business agility because of what we call a cost-neutral equation. If you want that job done in an hour, you have access to resources that will enable it to be done in an hour. If you think about the magnitude of this, and again, I'll use the example of the pharmaceutical space, in a business that is largely based on the time it takes from R&D of a drug to FDA approval, if you can start shaving minutes, days, hours, weeks, even months off of that time, that's translating into significant dollars, both hard dollars in terms of your costs, but also significant dollars in the form of getting to market quicker. So very, very powerful stuff, this notion of this cost-neutral equation. I want to finish up with want to finish up with just a quick example of the hard cost savings. So again, this does not capture the power of this business agility we talked about, but I thought it'd be important to share with the audience. This came out of a TCO study that we recently commissioned with a third party called the FactPoint Group, and we asked them to look at the difference between an in-house grid. So we took a typical in-house grid running commercial grid software and compared that to that same environment, that same job running in the cloud. As you'll see here, the savings are dramatic. So we're talking about orders of magnitude, specifically less than 1/4 of the price to run this in the cloud. And again, this is without incorporating the cost savings and the benefits you get from the enhanced business agility. This is actually available, by the way, in a TCO white paper. So you can get that at rightscale.com. And what we wanted to finish up with, we'll turn it over to questions now, but just want to give a couple shout-outs here and a couple reminders. One is, again, if you are in New York or want to be in New York next week, please come see us at Cloud Expo and the RightScale meetup. We do have, in conjunction with this launch, a white paper. This is a technical white paper that we've done specifically on grid computing in the cloud. It is available for download today. Just go to rightscale.com/grid solution. Also, as with all of our webinars, this webinar will be available. Give us about 24 hours to get the recording up there, but it will be available online at rightscale.com/webinars. And then, again, lastly, if you would like to try out this grid solution or see a private demo, please feel free to contact us at any time by phone or email or even Twitter, and we'd be more than happy to help you out. So with that, we're going to finish up here and address a couple questions. Feel free to continue to fire those questions along in the Q&A log there. But why don't we start off and talk a little bit about, there's a question here on latency between starting the deployment and the code actually producing data. So Dave, why don't you talk a little bit about that? This has a lot to do with where we're placing the resources.
Mm-hmm. So in this demo, we created the deployment from scratch and then spun up those servers. So in that case, you have to give it some time to bring up those servers online. But normally, our best practices dictate that you're going to have that environment already up and running, and the only factors that will affect latency is getting your input files onto those worker machines. Okay, so we have another question here. So batch processing jobs are normally predictable, thus it's easier to set up event-based management rules. But what about cloud computing data centers that have a lot of random I/O? How does RightScale help in that regard? So like I said earlier, you can have your environment already up and running. So yes, it does work well with predictable batch processing jobs. But if you have that environment created and you only have a couple servers up and running, when you do have those random I/Os, your environment will be ready to process those results.
Great. So Dave, here's another one around code deployment. Does the code go through RightScale or directly to Amazon? Maybe reiterate and talk a little bit about the inputs and the server templates and how we're pointing to repositories, so on and so forth.
Sure. So with the server template, it's really starting from a base image, or within Amazon, a base AMI. So when you launch that image, those scripts will run through at boot time, and in this case, it'll pull down your code from either your SVN repository or from S3, and then it'll load it back onto the server image.
Great. So the next question here: can RightScale help us move our server software to the cloud to be used by many customers? So absolutely, we have another initiative within RightScale that's around our ISV program. And what that is all about is enabling application providers to pre-configure their application to be available on the RightScale platform. And in so by doing, have that application be in server template form and be available across all of the resource pools that RightScale supports. So any ISVs out there or any folks that are looking to make their solution available to their customers or third parties, feel free to get in touch with us, and we'd be happy to walk you through that program. That actually dovetails into another question here, which is around, is RightScale dependent upon AWS? So RightScale is a cloud management system, and it is a multi-cloud management system. So, of course, if there are no cloud infrastructure providers out there that RightScale can interface with, then yes, of course, we are dependent. However, it is up to the user to decide the cloud resource pool that's most appropriate for them. So RightScale supports all of Amazon's cloud resources. We have also announced and will be rolling commercial availability for other clouds. The ones we've announced so far, Rackspace Cloud. We've also announced our planned support for Microsoft Azure. But it doesn't stop at the public clouds. There are many resource pools and a lot of interest, particularly within larger organizations and service providers, around private clouds. So RightScale will also be introducing a host of hybrid cloud offerings, allowing customers to take advantage of private cloud resources, but also give them access to public cloud resource pools through a single pane of glass, using a consistent design methodology, a single set of deployment assets, those server templates, regardless of what resource pool you're deploying on. Specifically, the enabling technology we've announced so far are Eucalyptus and vCloud from VMware. So stay tuned on more information about that. What makes that all possible is RightScale is dealing with a lot of the complexities around the various different resource behaviors amongst these different cloud providers. And an interesting point on this whole notion of multi-cloud is it actually starts with Amazon itself. Those Amazon regions are discrete clouds. So although Amazon does have many global parameters, so S3, for example, is a global parameter, SQS is a global parameter, many of the other parameters, particularly things like their image library, those are unique to the cloud. So the ability to take advantage of Amazon's multiple regions was actually the first area that RightScale focused on to deliver our multi-cloud solutions.
Yeah, another question here. Is there a way to avoid pushing/popping data to S3? Can we push or pull the data to and from RDS or simple DB instead? So what we showed in this demo was set up by default to use S3. What we didn't show you is there are more advanced configurations that can help you pull this data out of a database, in this case, RDS or SimpleDB. And there's also advanced configurations around posting those results to your own internal web servers so that you can do further processing on them or bring them back internally.
We had a request to put this slide back up, so while we keep talking here, why don't we move back over to this slide here for a few minutes. We had another question regarding the nature of our relationship with AWS and the support there. So AWS, as we all know, they are by far the furthest along. So just a tremendous offering that our partners at AWS have delivered. So we work very closely with them. We pride ourselves on being able to support very quickly after launch all of AWS's innovation. So that will continue. However, as more and more cloud providers start to emerge, part of RightScale's strategy and part of the commitment that we've made to our customers and to the marketplace is to be an open multi-cloud platform. So it is the customer's decision, not RightScale, as to which cloud provider they want to take advantage of. It's our job to make it as easily and as quick as possible for you to take advantage of one or more cloud providers that we support. So with that, we're going to keep the Q&A log open. Looks like we're at the top of the hour, so feel free to continue to fire questions our way, and we'll keep that log open. But this is going to end the audio portion of our webinar. So again, thanks for joining. Just another reminder, if you'd like this white paper, just please give us a shout, or you can just go directly to rightscale.com/gridsolution. We hope we'll see many of you next week. If you'd like to arrange a get-together or a private discussion, just shoot us a quick note at sales@RightScale and let us know you'll be at the meetup. We'll have many, many folks there. We'll have our CTO, our VP of Engineering. We'll have a lot of our technical architects present as well, including folks from our services organization. So you're going to get a great opportunity there to learn and talk to a variety of the different subject matter experts from RightScale, as well as hear directly from customers that are doing real commercial deployments in the cloud to date. And one of the customers, I don't want to steal their thunder, but one of them will be demonstrating and talking specifically about how they've used RightScale for their grid computing solution. So again, thanks for joining. We appreciate everyone's attention, and we look forward to speaking with you soon. Bye for now.